Good morning, everybody. How you guys doing today? Ads that don't even support the stream. Well, so technically, I do get a cut of the ad money, and that'll go towards the Student Scholarship Fund. So it does support the stream, maybe. How you guys doing today? Hopefully, you got your coffee. Things are going well. We're gonna finish up chapter 10 today. We didn't get a chance to get much into it on Tuesday, which is okay. We got a little bit more to talk about today. We'll look at the last couple concepts here in inheritance. We're going to talk about abstract classes and interfaces and what that means. And we can actually use that in this upcoming project, which is fun. Let me grab this here. All right. Right, and then just taking a peek at our schedule here real quick. Remember, there is break next week, so don't come. There's no stream. I'm hoping to get caught up on all the stuff I'm behind on now next week, which is good. Maybe enjoy some time. Right, so we've got winter break coming up. We've got midterm review on the 9th, and then the actual midterm sometime on the 11th. So my hope is I'll post the quiz for chapter 10, and then I'll also post like a sample midterm that you guys can take a look at if you want before the midterm review. If you don't until the midterm review, that's probably okay. I'd suggest you try the problems maybe on the 8th, Monday the 8th. You don't have to worry about it over break unless you want to. But yeah, try them on the 8th. I'll go over answers on the 9th, and then we'll have the actual midterm then. So the goal is for it to be, I mean, short-ish, not too long for sure. So we're going to look at having 15 quiz-style questions. So in the quiz-style questions are typically the ones that are like short answer, fill in the blank, like true, false, but if false, correct the statement style questions like you've seen on the quiz. But just nice short ones. And then we'll have 15 of those, and then 3 longer answer questions. Right, so we'll have something about classes and unit testing. We'll have a class, a question, not a class. So one of the 3, right, about classes and unit testing, one of the 3 about inheritance, and one of the 3 probably about text processing. We'll just kind of break it up that way. So we'll have those 3 long answer style questions. And those will be 5 points each. So that'll be half the midterm is that, and then half the midterm is the short answer questions. And that should be it. So I'll get you a sample one coming up. Make sure that's in my to-do list. Chapter 10 quiz. Example midterm. Sample midterm. Usually I give the previous classes midterm, but I don't actually haven't taught this one previously. So, there's that. And then we'll do that week, and then we just have a couple other topics. Exceptions, finally. Yes, I'm a big fan of exceptions. Advanced file I/O, and we'll have our last individual project. We'll do that for a little while, and then we'll come back to all of our Java FX GUI stuff. And then we'll talk about the final project. Last little bit of some notes on design patterns, and then I've got time set aside specifically for you guys just to work on the final project. And then still my hope was that we can present our final projects on 4/29. Won't be on Twitch, right? We'll fire up a Zoom call and do something here for that. You guys can present your final projects and show everybody else in the class what you got. We've been mostly, it's fine if things are asynchronous. So if you can't do it live, we'll look at other options for you, or maybe you can schedule a time to present just to me. We'll talk about that more when we get a little bit closer. But I think other than that, it should go well. If it takes 5 minutes to present, we can get a couple people. That's 12 people an hour. That's 24 people in 2 hours. I know it's not exactly 5 minutes. Some are shorter. Some might go longer. So we'll see. It might not be able to fit everyone in, but that was the goal, to have you present your final project. It is a lot of fun. Like, we're going to do a lot of work on this, and then also you are optionally able to do this one in pairs. So if we do have some folks take up that option and want to work on this in pairs, there'll be less presentations, that sort of thing. So I think it ought to work. Okay. That makes sense for the schedule here. So we are about halfway done, amazingly. Today is the halfway mark. 1, 2, 3, 4, 5, 6, 7. Yeah, well, I guess there's 8 weeks here, but yeah, it's flying by, friends. Definitely flying by. All right. Let me pull this one up here real quick. I want to make sure I'm not missing anything important here. There we go. I'm getting forgetful here. Oh, you got a calculus test, sweet tea? That sounds like fun. What's the panic for there, Snake? The surprise. Yeah, and Scholar, yeah, the GUIs will be a lot of fun. We actually have something we can click on instead of all these command line programs, so it'll be good to get into. Getting JavaFX set up is another one-time step that once we're done with it, it's going to usually work really well, and we shouldn't have any problems. I saw some chat in Discord about some people using Visual Studio Code or possibly some other IDEs. NetBeans has some really nice shortcuts in there for us when we're doing stuff with JavaFX, but it's you don't have to use the shortcuts, but I'm just a big fan of shortcuts, right? The more work it can do for me, the less I have to do manually. I'm always going to be all about that. All right. All right, so let's see. Class is winding down. We got a final project, more chapters. Yeah, there's just a lot. In real life word ban. I'm not allowed to say the name of the IDE because IntelliJ is the best. Okay, that's fair. That's fair. I'm not going to switch IDEs though. I just won't mention it by name here. Yeah, I'm sure I could give it a try. Dr. Ball uses this one, so I started using this one. We also use this one for the web development PHP JSP class that I'm teaching. So it works out well that like all the stuff I do is in the same IDE. We don't do C++ in it though, because Visual Studio is definitely the superior IDE. Scholar, you ban the name of the other IDE. Oh, that's good. That's good. Oh, here, just because you guys are using your points on the word bans, I've got a free dad joke for you here. This one's on the house, because I found this one and it was awesome. So I was just reading yesterday. Yeah, JGrasp. It's a fine IDE for like, I just want to write some quick Java code and have it run. And that is what one of my fellow faculty members said is great about it. That he tells people to download it and hit run and it just goes, which I can appreciate. And he's frustrated with Dr. Ball and I that we have said we should use NetBeans because he said it just causes all sorts of problems. But anyway, so I'm a big nerd. I'm in the Knowledge Fellowship. A shout out for the Knowledge Fellowship. That's !TKF in the chat there. I'll give you the links. And there's all sorts of cool science stuff we can learn. We got some chemists on there. We got some biologists. We got all sorts of other cool things that you can learn about there. And it's just fun to hang out and chat with people. So I just read that we've been working on some of those like cell growth techniques to try and like grow organs essentially, like in a petri dish for replacement, so you don't have to get an organ donor. We can just grow one. And they said they finally have grown the first vocal cords in a petri dish. and they said the results speak for themselves. Yeah, that was a good one. All right, let's find 2100 or 2151. We were looking at chapter 10. I'm going to do a quick recap here. Yeah, no, that was a pretty good. I found that one last night. I was like, you know what? Class would love that one. So, we have a couple cool things, right? Inheritance, this is the extends keyword, creates this is a relationship. So a rectangle is a polygon. Right? When we have inheritance, we get one particular sticky point is constructors that we're going to have to look at. If we're inheriting from a class that has a constructor that needs a parameter, a parameterized constructor. I don't even know how I can do that, sweet tea. I'll try. I will try. So if we have a parameterized constructor, when we do inheritance, we have to call that superclass constructor and give it parameters. Now, it could just be hard-coded. In this case, we know a rectangle has 4 sides. If we wanted to, right, there's nothing wrong with saying, hey, my class here is also going to take an int number of sides. When you make a rectangle, you just pass me a number of sides, and I'm just going to hand it to my parent class constructor. Perfectly fine. There's not a problem doing it this way, right? If we don't know what it is, or if it's supposed to be a variable, right, we just need to also then have a constructor that takes that variable so we can hand it to our parent class. Okay? The example of rectangle, we just know it already has 4 sides, not a big deal. In the case of square, extending rectangle, it just calls it superclass constructor, which is a no argument constructor. In this case, we don't actually have to do this line. I wanted to put it here to like call it out that this is what's happening. So if your parent class has a no argument constructor, it will happen automatically. Right? The first thing that happens in your constructor is it goes to your parent class and runs that constructor. Right? The reason why is we need to have all of those attributes and variables and things set up before we can do our thing. Right? If we didn't initialize our parent class here, setting side length would fail because, remember, the rectangle class will initialize the polygon class, and polygon in the constructor's job is to give all of our attributes values. So it sets up side lengths as a new array list. If we don't have this line, like you saw me fail lots of times in poker, it crashes. You get one of those null reference exceptions because you're trying to use something that you haven't initialized. You declare it, and the constructor initializes it. Okay, so that's why we have to do that, the chain of, hey, call the parent class constructor first, then I can do my stuff, because I might be dependent on their attributes. Okay, so it's always the first thing that your constructor does. Okay? So another thing we can do, we didn't talk about this one yet, but we could here, we can make another constructor, right? You can overload constructors. You can have an int for length and an int for width. So if you want to have a constructor that takes no arguments and then go set the side lengths, great. If you want to have a constructor that takes arguments, great, nothing wrong with that. We still need to call our superclass constructor, right? Then we need to call our own set side length, right? And we're going to say, oh, actually we didn't give a set length and set width, did we? That's fine. So we'll call set side length, and we're going to say, hey, for index, we'll go with 0, right? Was probably the length. Oh, it'd help if you could spell that right. Length. And then we'll set side length for index. No, that's not the one I wanted. Set side length for index 1, and this time we'll give it the width. Hydration, yes, thank you so much. Thanks, Snake. Coffee time. And I love this. This mug is great. I had my other mug yesterday in class, but it's smaller and it ran out so fast. I was so sad. Like I'm used to the large volume mugs now that this one is. That when I had like a regular size coffee cup, like it was gone right away, and I was really sad. I had no hydration. Although it was the espresso that I made in my little mocha pot. So I essentially had like 3 servings of espresso in this time span of less than an hour. So I was feeling real good yesterday morning. Real good. Okay, so this is overloading your constructor. Right, so this is a constructor overload. Just like we can overload methods, you can overload constructors. Right? We're allowed to do it more than once. What is it complaining about? Overrideable method call in the constructor. That's fine. That's fine. That's okay. Okay? So we can have more than one constructor if we want in here. It's hard mode. So this is something we can take advantage of as well, but remember, we're still calling our parent class constructor. Okay, so we're calling that out. We can override our superclass methods, right? So we wanted different behavior. We wanted specialized behavior of set side length. But what we also wanted to do, we wanted to take advantage of our superclass's version here. So we're using a superclass version to access this. So this was before we looked at this protected keyword here. When this was private, we didn't have access to side lengths. So the only way we could interact with it is through the public method of set side length, which is fine. Like if that's what you want to do, there's nothing wrong with that. You don't have to make attributes protected, but if you want to, you can. So set side length then is going to use the superclasses version here. So we're overriding it. We're saying when you call set side length, run my version. But what I'm going to do is I'm going to use the parent class's version here. Okay, to give me the correct behavior. So I'm specializing its behavior because I want to do the correct thing for my class. Because I'm different, I'm a special version of Polygon here. So I want to make sure that my lengths and widths are always the same. Otherwise, I'm not much of a rectangle anymore. So if I don't override it here, bad stuff is going to happen and I won't be a rectangle anymore. And then like getting area is going to be all screwed up. Because then you're a trapezoid or something, right? If you change your lengths and widths or something. Okay, so we're overriding there. Okay. It's worth noting, remember, when we look at a method's signature, it's name and parameters. And this is how we tell whether or not we've overridden something, is if we have the same signature. So signature is name and parameters. Just like when we overload methods, we have to have different signatures. When we override methods, we have to have the same signature. Because otherwise it's not, right? If it was set side length and we took like a width length and a width here, we're going to have a different signature. And now Java tells us, hey, this override tag, you tried to override something. You told me you wanted to, but you're not actually doing it. So that's why this little annotation here, the at override, is helpful, because then Java will check it for us and say, I don't think you're doing what you mean to be doing. Right? What is that? What is that meme? It's like you keep using that word, and I don't think it means what you think it means. That sort of thing. Yeah, sure. So one of my friends, Professor Peter, who teaches math somewhere else, I forget where, he gave an assignment to his math class to create math memes, and it was hilarious. He was posting them all on Twitter, some of the best ones the class had come up with. It looked like just a fun exercise, so I'm tempted to do that, to have you come up with a Java meme here. Oh, someone had asked me what my favorite language was. I'm sorry. If I missed your question in chat, just hit me again, because I get distracted easy. I don't know if I have issues with focus or not, but I might. It's possible, you know. It happens to the best of us, or the worst of us, or just the regulars of us, whatever you want to call me. So my favorite programming language, I think, is actually C#. I'm a big fan of C#. It's been a lot of fun. It's very similar to Java, but it runs in the .NET environment, and you get to use Visual Studio to program with it, which is like the best IDE in the world. It's a little slow because it does so many things, but Visual Studio is just fantastic, and I love it. Okay, So maybe if I could program Java in Visual Studio, Java might be my favorite. But, you know, so Java, not the first language I learned, but like the first language I like really did a lot with. So that was the first language I learned in school back in, wow, when was that? The winter of 2005. Yeah, winter of 2005. I first actually took the 1500 course at OCC. That was a lot of fun. Someone had posted, oh, where was it? That, hang on. 3D printed. Let me see if I can find this one. This one was worth it. Yeah. This floppy disk. Oh, wow. You 3D printed the save icon. Oh, that one hurts. That one hurts. And, you know, course management tools like Desire to Learn and sorts of things were still not super commonplace. And I don't know why I tell you these stories make me feel bad about being old, but we had to turn in our programs in 1500 on floppy disks. So every week or every whatever, when our assignments were due, the prof would have like a disk holder, a little like this like little plastic thing with a lid that would open and close, and we had to write our name on it. And I have weirdly fond memories of that being a funny thing. Okay, so yeah, we saw this, and then someone shared it at work, and they're like, "Oh, you know how you're old when you see this," and someone says that, whatever, and then he's like, "Oh, this one hurts twice because I am old enough that I remember this, and then these memes about getting old are now hitting." So, okay, that was a good story, right? I don't actually have a floppy disk here in my office. I have one down in my basement. I could go show you one if you were curious. Yeah. They used to make a USB adapter to read floppy disks. It's like computers haven't had slots for them for a long time. But yeah, I built a gaming computer in 2004 for fun. I talked my parents into getting me that for like my Christmas present or something. It's like, hey, I want all these parts and I want to put them together and make a gaming computer. And they're like, well, that sounds fun. So that's the nice benefit of having engineers for parents. Oh yeah. So he'd give them back after you submit. So he would go through and have to run them all. The 5 1/4. I never had the pleasure of using one directly, but as a kid, we would have games on the 5 1/4 big floppy disks. I don't know why they called the small ones floppy, because they were hard. The big ones were floppy, and like you could bend them, and you just had to be a little bit careful with them. But okay, that was story time with Eric. He's an old guy now. So inheritance, right? Overriding. If you want to not allow people to override, you can use the final keyword, so that you can't change your method behavior. So they just get an error if they do try and do that. Sure. Protected makes it so that you can access your attributes in the child class. So protected is really cool. Like if we know we're going to be inheriting, like if we design this to be inherited, we can say, hey, this will be protected, and that way they can access side lengths directly. So that way, instead of having to do this thing here, we could just say side lengths dot set, right? No, not that set. Why? Right, 0 in length or something. Right, we could do it directly. So we can do this with protected access. You can access it directly. Okay. So we were trying to do it without, right? So and either way, depending on what you want to do, can work. Because you might not always want to give public access to certain functions. So like we had set side length be public already. Great. If we didn't, for whatever reason, we'd want to give our child classes a way to modify those values. Right? We could either just set the attribute to protected, or we could add a protected method, which is like one of those helper methods, like a private helper method, like we looked at for the poker project. Hey, this is just going to do something for my class, but no one else needs to use it. I just want to use it internally. We could add a protected method as well. So just depending on what your requirements are, and what we need to do here, we can do it one way or the other. Okay. Inheritance, yep. Everything inherits from object. Remember, object of the toString thing. And then, okay, the last thing we talked about here was polymorphism, which is one of my favorite things here. And we looked at, because we have this relationship, right, where we all are polygons, we are one of these things, right? It's a you are relationship. See what I did there? Yep, I'm trying to onto that word band. So a square are a polygon. Rectangles are polygons, and squares are polygons. There we go. I did it. And it even sounds like English. So we can treat them all as polygons. Now what that means is we still have methods like set side length, because polygon has a set side length method. What we don't get is anything special. So we have no access to get area, because it doesn't know that it has a get area method, because we said, hey, treat this thing as a polygon. But we can use get perimeter, which is fun. We can call set side length, which is fun. And then what happens with this polymorphism is at runtime, when we call set side length, it's going to actually map it to the overridden version. So we looked at this in debug mode. I did? Oh, I was trying hard not to. So it's going to do the overridden version here. What is that like? Have you guys seen Monty Python and the Holy Grail with the knight who says knee and the word that must not be said? It's like one of those things. Oh, I said it again. Oh, I said it. I said it again. Stop. And that was, yeah, sure. All right, so in debug mode, right, where we have shapes, we're getting the first index out, so index of one shape, and it's set side length. Then we step into here, into set side length, we're actually going to get the rectangle version, because at runtime, it's going to match it to the correct instance. Right, so that's what polymorphism is. We can treat them all as the parent class type, but at runtime, if we call methods, it's actually going to run the correct overridden version, because it says, oh, you actually are this type. We need to do that one, which is cool. So that's our polymorphism. Do this. Okay. All right, now we can move on to abstract classes. Abstract classes are really fun. So let's take a look at what's a fun one we might want to do here. Okay, so let me add another class here. We're going to make this animal. Okay, and to be an abstract class, we add the word abstract here. We say we're a public abstract class animal. What that means is we are allowed to have abstract methods. I know I keep using the word and not telling you what it means, sorry. So remember how we look at those fundamentals of object-oriented programming. We have inheritance, we have abstraction, we have encapsulation, which is usually goes kind of along with abstraction. Not always the case, but a lot of times it's encapsulation and abstraction here. And then polymorphism. Look at some of our fundamentals. Abstraction means we don't care about the details. What we care about is that public interface here. So I don't need to know how the Java scanner class works. We can go look it up because it's open source code. But I just need to know that if I call next line, it gives me the line of code or the line that you typed in at the console. Right? We get to interact with it in this abstract manner. So in that similar vein, an abstract class or abstract method says, here's what the method is. You need to go actually write it. So it lets you create a parent class and have unfinished methods, but that way you know, hey, there is a method with this name in it here. So animal, we're going to have like a couple attributes here. So we'll have a private string for name, we'll have a private string for color, I guess, and sure, why not? And then we'll have a constructor animal that takes a string for name and a string for color. Why not? And we'll have this name as the name. We'll have this dot color. Nope. This dot color is the color. Sure. And then we can add an abstract method. So we're going to say, hey, public abstract string. So we add this keyword abstract here, just like we did for our class. So it's going to return a string, and we'll call this one, I don't know, well, make noise. This is always a fun one. Oh, it's just a semicolon, sorry. So we just end with a semicolon. Okay, we don't use curly braces because we're not actually defining anything. We're just saying, hey, if you want to inherit from this class, you will have a method named make noise. You tell me how this one is defined. I'm going to say it's there, but I'm going to leave the implementation up to you. So what's fun with abstract classes is you can't make them. You can't create an instance of animal. Here, if I go to chapter 10 and I want to say, hey, I want an animal, a dog equals a new animal. And if we wanted a dog for the name, or I don't know, Fido for the name or something, right? And maybe Fido is beige, I don't know, yellow, golden. How about golden? It's going to yell at me here. And the error is animal is abstract, cannot be instantiated. Yeah, you can tell your method it can return any type you want. It could be void, it could be a returning type, it doesn't matter. Any way that you want to define it, your choice. So because it's an abstract method, Java won't let you make an instance of it. Right? So then what we can do here, right, we can go add another class. Class. And let's call this one, how about dog? Sure. So dog then extends animal. So dogs are animals, right? We're creating that RA relationship here. And now I'm getting a warning. It says dog is not abstract and does not override abstract method make noise an animal. So you have options. The second one here is probably not what you want. We said, oh, we could make dog abstract. And we could have a inherited class that is also abstract that would then have to be implemented again in another class. We usually want to avoid that. You can do all sorts of cool things with abstract classes that inherit from abstract classes that inherit from abstract classes. Don't worry about that. We'll do that in data structures, okay? We want to implement the abstract method. So it adds the override tag, adds a make noise, and then its default throw unsupported here. So we know dogs make a woof noise, right? So we're going to return woof, right? Okay, here. I got a better one. Here. So we're gonna add an app. We're gonna say dog has a private double for weight. Okay, and then we're gonna write a constructor for dog. So public dog. Now remember, the animal class has a constructor to set these attributes. Okay, so dog, then we probably need a string for name and a string for color just to pass to my superclass, and then I also want a double for weight. Okay, so we're going to call super given name and color to call that constructor because it needs parameters, right? Then I'm going to set my this weight to the weight. Here in animal, we should probably add some get methods here, right? We want people to be able to get those attributes back out. So I'm going to go insert code. Actually, I'm going to do that. Yeah, that's fine there. Why not? Insert some getters. Yes. Okay, we got some getters. Dog, I also want the getter here. I'm going to insert the getter. For weight, sure. Okay. Now make noise. Now we need to change this. So we're going to say if weight is less than or equal to 15, let's return yip. If it's a small dog, it yips. Otherwise, right, we don't even need the else because it's redundant. If we did not return, then the next part of code can run. But if we did return, I don't need to bother wrapping this in an else. Woof. So if we're a small dog, we yip, otherwise we woof. Okay, and that's how we define make noise. Okay. Now what I can do then is I can make an instance of dog. And we'll say, hey, its weight is, how about 20 pounds? Now I can still say, hey, it's a type of dog, or a type of animal, if I wanted. Because dog doesn't have anything special aside from its constructor. I guess we have get weight. But I can still treat it as type of animal, its parent class, if I wanted, right? Or we could put it into an array of animals and loop through and have Old MacDonald on a farm, and each animal gets to make its noise and do all sorts of things there if we wanted, right? If I wanted to entertain my little guy, we'll sing Old MacDonald Had a Farm, and I could put all of those animals that we create, all of the subclasses of animal, into a list of animals, and they can all make their noise, right? Dog.makeNoise. Right, we can print that. Okay. We can do that sort of thing. So abstract methods force us to implement them in the inherited class, in the subclass, in the child class. Okay? Does that part make sense? Like, this is an abstract, so it can have definitions, it can have attributes, it can have methods, right? They're all there, but it has at least one abstract class, or abstract method here, right? So when we implement it, we extend it, right? We are one of these, so dogs are animals, right? We can add our own stuff, and then we override the abstract method. We can override other stuff as well, but we have to override the abstract method. Okay, so what we might want to do then, remember when it comes to the project here, let me pull up the project. You guys know I'm a giant nerd, it's no surprise. I spend time watching Critical Role, voice actors who play Dungeons & Dragons, and it always inspires me to try better accents, and I'm terrible at accents, so if I use awkward accents, it's just because I want to be cool, and I'm not, but just forgive me if you would. That override annotation is to make sure that Java does the checking for us, to make sure that it actually matches. So, like if I say, oh, this is void here, obviously I can't use these return statements, but like it's still going to fail and say, oh, it doesn't override anything because the signature doesn't match. Right. Void is not compatible. So it's just double checking for us. So it adds a little extra checking at like in the IDE or at compile time to make sure that it actually does override. Okay. So the next thing that we can do is, oh yeah, sorry, we were talking about that for our project, right? So our project says we need to create a base class here, cart. So we're going to have all the things that are common to cart here, but you can't make a generic cart. So it makes sure that whatever makes these carts special, whatever those abstract methods are handled by the subclasses. So if we have some shared components, but we don't know exactly what they're going to do differently, we can have subclasses then that will implement those differences. Right, so all carts will have speed, these sorts of methods, they can accelerate, they can reduce their speed, they have all of that, right? What's different with light carts is when we enter a bend, we need to do special things. Right, so there's probably some sort of method like enter bend that we should make abstract, and we'll let each class implement it separately. Right? Or with heavy class, like with items. So not everything needs to be an abstract method. Well, Mighty Core, it doesn't know to check if you don't use the override tag. So the override tag just tells Java, yes, specifically look to make sure this one overrides. Yeah, so cart's going to be abstract. So And then we can override specific behavior here with these. Because we don't want anyone to make a generic cart. We want them to specifically use the subclass types here of light carts, heavy carts, and motorcycles. So like anything that's shared among these can go in cart, right? All of its attributes, the general methods here, and then specific versions or things that we know we want to have the classes do differently, we could possibly leave abstract. Well, like, these attributes can go in the abstract class. They don't need to be abstract methods because like we know what accelerate does. It increases their current speed by their acceleration or up to their acceleration. So maybe it's accelerate given a number, and then it can check itself to make sure it's not trying to go faster than its max acceleration, right? So maybe you only want to accelerate 1 unit instead of like 5 units or something like that. Brake, up to your brake speed. So if you want to maybe just slow down just by 1 instead of slow down completely or stop, that sort of thing. With get attributes. And then this use item method here, this is common, right? But what we can do then with heavy carts is when we can add item, right? We need to change its behavior so it can act, when you go to add, it can take a second item and store it in something specific to heavy cart. This heavy cart has room for another item storage or something like that. It's got a bigger trunk. I don't know. Whatever we want to pretend. So then when we use an item, it should shuffle those around and say, oh, the second item now becomes the first item, right? So I'm always using that first item, that sort of thing. And motorcycles, when they slip, maybe we need to change the behavior so they lose a turn once they've slipped. It's like the next time we try and move, if we had just wiped out, we shouldn't move, and then the time after that, then we can move, that sort of thing. Okay. So we're going to use the abstract class here. Now, taking that to the next level, we can look at, sometimes people call them a purely abstract class. We have a word for it in Java and other languages called an interface. And an interface is just a bunch of abstract methods. So let's call this one, sorry, what do I want to call this one? Animals. We'll call it movable. Sure, why not? So movable, now we change the name. So it's no longer a class. We say it's an interface here. Movable. And what that means is the only thing we can do is have abstract methods. You can declare fields. You can have fields. Usually they're final and static, so like that's not always useful. So if you want, hey, here's like a shared definition for something here, we can put them in there because they're final and static. That's okay. But what this lets us do, so if we are movable, then we're going to say we have a, I don't know, we'll call it a string run. And now with interfaces, we don't use an access modifier here typically because it only makes sense to be public. There's no point in having anything other than public. So public is the default access modifier on interface methods here. So we can run, we can have a string for walk maybe. Sure. So what we can do then, remember in Java, you can only inherit from a single class. We have single inheritance, which makes sense, right? Because you only are one thing, right? Some languages can let you do multiple inheritance and it gets messy and crazy and all this weird stuff. which you can only inherit from a single class. But what you can do is you can implement interfaces, as many interfaces as you want. So we'll have movable, and then we'll have another interface like pet. Okay, and we'll say this one here then is an interface for pet. And this one, I don't know, let me just return strings, because why not? Oh, thanks so much for the stretch. Sorry, I'm getting stuck here in my seat. Oh. So if you pet your pet, I don't know, pet, why not? You can pet your pet. Right? Maybe a string for give toy to your pet, I don't know. Play with toy. Why not? An apostrophe, yes, thank you. Let me get on my backboard here again. I'm not slouching so much. And hydration, all right. Coffee time. Cheers. Oh yeah. Man, I should have put it in my thermal mug. It's getting cold already. All right. So we have interfaces. If you're a pet, you can pet your pet. You can play with a toy with your pet. If you're movable, you can run and walk, that sort of thing. So our class here then can implement. So we extend animal and we implements. There we go. Pet and movable. And now it's yelling at us. It's saying, hey, we don't override these methods. It's not abstract. So it's using that same idea of these are abstract methods, but we're just saying, hey, basically it's a list of abstract methods. So let's implement all abstract methods. Then we get pet, play with toy, run, and walk. Okay? And we can figure out what we want these things to look like. Play with toy, pet. So we'll return, we have a name, right? So we have, like, we'll say get name starts shaking its, or it starts scratching with its back leg. Scratching. Back leg. Quickly. You know, like when you pet a dog and it goes like, and like you get its leg going? Sure. So that's what happens when you pet a dog. When you play with a toy, let's return, we'll use the name again, right? Why not? Starts being into the new toy, and it shreds. I have to buy another. Sure, why not? Again, just silly stuff here. We're just having fun. Return, we'll say get name. Yeah, why not? Quickly outpaces you and pees on a mailbox. I don't know. Sure, why not? And one last one for a walk. Return, get name. Pulls constantly on the leash. And you think your arm is going to fall off. Sure. Just any way we want to implement these things, right? But the idea is that any class that implements this interface will have that method. Right? So again, we can kind of treat them with that polymorphic behavior if we want and say, okay, sure, I've got all of these classes of a given type. You can treat them as a type of interface that they are. We could say, hey, I want a list of pet types. And any class that implements pet, I can throw into that list because it's polymorphic. Now, remember, when you do polymorphism, you only get the methods defined at the parent class. So if I want a type of pet called a dog equals pet, we'll say other dog, I don't know, dog equals a new dog. This one will be Bingo, right? And Bingo was, I don't know, black and white. Imagine he had spots, right? And Bingo was big, right? Bingo was like a big 50-pound lab or something, right? So Bingo, we can save our dog. We can save as type pet if we wanted, and then other dog. When we other dog dot, all we get are the methods that match pet. Right? So we get pet and play with toy. Again, we don't have to do that. Right? We could just let it be a dog, And then other dog now gets the rest of the methods. We can get weight, we can make noise, we can pet, we can run, all the methods that it has we could use. But if we wanted to, right, we could treat it as that parent type and get that polymorphic behavior. That's sort of the idea here with our interfaces. So our items then, in our project here, right, we might have an interface that all of the items implement. Right? We could do something like that. We could say use, perhaps. And they would all have a definition for what happens when you call the use method. And that way we can say, hey, or it could just be the interface type of item. Right? They all would then implement that interface and give us that use method in addition to whatever things that they wanted. Right? But the idea is that the use method would be the trigger for that. Yeah, let's do that. Let's do that here. So let me add that in here. I'm sorry to add something last minute, but I imagine you're not done yet. So I'm not going to feel too bad. No one's submitted yet. So create an item interface, a method for use. And use probably needs to know a couple things, right? It probably needs like to know which character's using it. Or which cart is using it, perhaps, given the cart. Right, and whatever type we want to do here. Right, depends. Right, because mushrooms are going to speed you up, so mushrooms will just accelerate a cart above the ability that it should be accelerating. The shell item, when you use it, we're going to have to tell the track, hey, shoot the next car ahead of me. Just assume it's like a red shell and will always hit. If anybody's in front of you, it'll hit them, and we'll just call it instant. And the banana peel drops on the track. Right, so cart probably needs to know the track that it's on or that sort of thing. So we have to kind of puzzle through where do these things fit. So use a cart. Yeah, sure. Oh, blue shell. Well, this one's just the first one in front of you instead of the first place one. If you want to do a blue shell and shoot the first place one, that's fine too. Either one's okay with me. Right, so all these classes here then. Here. Mushroom item. So implement. Create classes that implement the item interface. So mushroom, banana, and shell. Okay? Does that make sense? So we'll make this method like use for a given cart. A cart will use an item. Because remember, carts will track their items. Cart will have property for items. And we can just, when we're holding these things, where did I put it here? I said only one item, didn't I? I'm losing it now. Yeah, a cart may only have a single item. So the cart can have a type of that interface. And all it has to do is know that it has to call the use method. Right? We don't need to have a type of mushroom item. We don't need to have a type of shell item or a type of banana item. We just have a type of item, and we can use it. It will do the right thing, right, based on its class implementation of use. That way they can all have different behavior here. Yeah, large carts can have two. So the large cart here can store two items, so its add item method should be able to take a second item instead of just doing nothing. Right? If you try and add an item to a cart when it already has an item, nothing happens. Right? And when you use an item, right, you tell the cart to use its item, then it will go use the first item and take its second one, drop it in the first slot. So it's got room for a second. But that way it's always only ever using the first one here in large carts. We're just kind of having some fun designing it, trying to figure out how we can fit these pieces together and use some of these tools here. And the nice part about this, if we use an item interface, right, we can then come up with other items if we wanted to. Right, we can add other things like ink, or we can add like a star, or we could add a bullet, or I mean any sort of fun items we wanted, sort of things. As long as they have a use method, we can define them. Right, we can just add more implementations. So it kind of gives you some flexibility. So interfaces are heavily used in the world because it lets us define later what we want it to actually do with here's the shell of what it looks like. Or the sort of idea that abstract representation of a class is here's a public method. These are the public things you can do to it. So if we use an interface, like here's the public things you can do, figure it out later. Or I don't care how your class does those things, I just know you'll do something. Okay. Oh, I got 11 o'clock. I think we're due for a break. We'll come back. We'll talk a little bit more. Let's see. I think we're almost done, actually. Yeah, we've got interfaces. Yeah. Let's see. Yeah, we got a little bit more we can do. We're close. Okay. Hat. Yeah, I'll grab my hat. Thank you. I'll go grab some more coffee, and we'll go from there. All right, while we take a quick break, I'm going to save that. We'll come back to this one. Let me throw some more music up for you. That's not where I was. I wanted this one. All right, we'll take a quick break. We'll come back in a little while. Say 11:10. I'll pick it up from here. All right, folks. I'll see you in a couple minutes. Hey everybody. Wow, that went by fast. Alright, I can probably close that down here. Let's see, I was taking a peek real quick at, not that one, the source code examples. I don't know if you guys went and actually downloaded any of his examples from the Pearson website, but I went and did that real quick for you guys. So I'm going to add that to, I don't know, we'll just textbook code examples, and I'll throw that up here for you guys in case you didn't have it. So I've got all those here as his zip. It's got all the chapters here. Again, we don't need all of them, but it's easy enough to just keep them all here. So I grab those, and I'll put those in for you here in D2L. Because he had a couple examples here from chapter 10 that you might have wanted to look at, in case you weren't following along right with the book. You just want to open it up here. As we look at some of these last little bits here. Okay? So I put that there for you. So hopefully that'll be out there in D2L in just a minute, in case you wanted those. All right. Awesome. Yep. So the source code's out there. You can just download the zip and have all of those. Should be in good shape from there. Okay? All right. So last couple things here. There's a newer feature in Java 8 and beyond that lets you have default methods in interfaces. Again, it's a little bit awkward and kind of breaks the definition of what an interface is if it has a default definition. I'm not a big fan of it, but like sort of the idea is that you can then update interfaces, add a default implementation to a new method, and then anything that's using that interface doesn't have to go and change. So trying to make it a little bit easier, I guess, for updating existing interfaces. Which, sure, that's all well and good. And then we've got another crazy thing we can do here with what is called a lambda. So there's this idea that we have an anonymous class here. That's not what we want. There we go. So what... remember, you can define a class inside of another class. No, not Half-Life. So an anonymous inner class. You might have done them back when we talked about GUI programs in 1500, where we had the event listeners. You could implement event listeners a couple different ways, and one of them was to make anonymous inner classes, where we'd make a new event listener and we kind of define it right inside of that code. I don't think I did that as often. I'm trying to remember now. Let me go look. Let's see if we did that or not. It's 1500. Yeah, sure. Let's take a look at one of these. Let's see. So we did GUI stuff. Let's see. In the controller, did we add and listener? Nope, I must not have done that. Oh yeah, because we just had our handles. So yeah, we didn't bother with any of that. So doing it the non-FX way, you had to do some. Don't worry about it. We'll talk about it more when we get into GUIs. I don't want to have to jump into that and then come back here. Yeah, I think it's the same way. I'm not very familiar with Kotlin, but I'm assuming because it's Java-esque, it'll be the same thing. What it lets you do is have like an anonymous definition. So if we have a interface, let's call this one, I don't know, we'll call it sleep. So again, we change this to interface, and it has a string for sleep here. What we can do is we can make a quick definition for it. We can say I want a sleep, this is snore, right? And what it lets us do is define it in a way that just quickly gives us back this. So, okay. We could do it as an inner class. We could write another class here inside. Right? That's some class that snore class snore implements sleep. Right. And we can have an inner class. sleep, snoring. And, there's nothing wrong with doing it this way. That's fine. We're going to return, I don't even know how you'd spell this snoring noise. Arg. Sure. We could do it that way. But it turns out this is a lot of typing here, right? Just so that we can use this thing up in the rest of our code here. Right? So maybe if you have some sort of dog that snores, we can have the dog do that sort of thing. But this is just, hey, here's an interface we want to have the definition, right? So let me grab this one here. So what we could do instead, right, is we can define it inside of our code in a single line with a lambda. We're going to say sleep. This is, I don't know, quiet sleeper equals, and then we use this arrow notation. A quiet sleeper just oh, no, it doesn't. Oh, shoot, we need, what do we need there? Should be fine. It doesn't like it. Why does it not like me? Yeah. Start an expression. Leave it that. There we go. Okay. So because sleep doesn't take any parameters here, we say no parameters. Then what I can do, I can take quiet sleeper and I can call the sleep method on it. And it will give me back here. You print that out. Okay. Got our parentheses. All of that so that we can get out. So you can see having this done in one line is nicer than a bunch of lines. Because, right, we want our code to not have lots of lines. But it creates this anonymous class here that implements the sleep interface. And what it does is the only method it has, sleep here, is then defined, saying, oh, no parameters, right? You do this thing, return here. So you can also do methods then that return values. I'm sorry, that like take parameters. So you might have one, I don't know, sure, why not? Let's try, how about we'll say some math. So this is an interface, some math. Then we want to say, I don't know, add int first and int second. And it returns an int, right? And not an int here. All sorts of lines. So if we wanted to do some math, right, we could say this is a type of some math. This is multiply for whatever reason, sure. So it takes a first and a second. Whoa, first and a second. Wow, that was neat. And then it gives us back, right? It recognized, hey, it's a lambda here. What's it? It's going to, oh my goodness, stop. Keeps typing all the wrong characters for me. We're going to be first plus second. Oh no, first times second, sorry. Yeah, maybe we don't want to call it add, we'll just call it math. There we go. So then we can take multiply, we can call .math on it, we can give it, I don't know, 5 and 20. And it will do the math method given these parameters. again, these are all real contrived examples here. But the idea is we can define this anonymously with a lambda. Here, that's this little arrow syntax, is the lambda. And these are becoming more and more popular because if we can do it in a single line here instead of a bunch of lines down below, it's nice. Right? So it's just saying, oh, we know you want to implement that single method. Sure, let's do it. It's easy. Now, like our interfaces here, like pet that has 2 of them, those ones get to be harder, right? So if we wanted to have, this is angry pet. Right, it's not even going to let us create the lambda here because it's not a functional interface. So a functional interface means there's just one function, one method. So it only works with interfaces that have one method. So if you wanted to, right, the item class could be a functional interface because it only is going to have use. But you probably don't want to have to do all of that code inside of a lambda, though. That sounds terrible. So they're not always the best thing, but they definitely can work. You can't use lambda on face with more than one method, right? It's not functional. Functional interface. Okay, so we won't do that. Okay, and I think that gets us through all of chapter 10. This last part's I'm not going to ask you guys to use the lambdas. I just want you to know they exist, and you might see them places. That's all. Okay. So how are you folks feeling so far about chapter 10? Like, obviously, we need some practice here, but yeah, lambda coffee. Chapter 10 feels. All right, so let me start out a little Twitch poll here, and tell me how you feel about chapter 10. Give me some feels here. Is it just a what? Uh-huh. I sort of get it. I need to practice it, or I'm gold already. Just let me know how you feel about chapter 10. And I'll push all this code out to GitHub. Now, something I miss, but that's okay. It's from my .NET days, is interfaces, the names of interfaces. I'm a big fan of putting an I here. They don't usually do that in Java, which makes me sad, but if you see me do like iMovable or something, it's because it's an interface. It's just a convention we use in .NET land. I try not to do it here, but you might see some crazy looking interfaces from me. So if you do, don't worry too much about it. It's just something I like to do. Okay, this is more chapter 10. I mean, you've seen it, Scholar. No, it's definitely got to look at more examples and play with it and practice it some more. So, lots of people said they need some more practice. Awesome. That's good. That's good. All right. Don't forget, we do have study group today at 4, and then no study group over break. And no lectures over break. Hopefully you guys can actually take a break and be in good shape from there. All right. Any other questions, or should we call it a day? We need to get started on project 3 if you want. Yeah, take the week off of classes, right? Oh, sorry, Snake. This is the inner class. So the inner class is not anonymous because we have defined it. Okay. All right. I don't see a lot of questions. Should we see if there's anyone around to pester in Twitch land? We can go see what they're up to. see what we got. All right. Oh, that's an ad. Now, I don't see that Psychic Queen online. We rated her, I think, last week. So we'll just call it a day. We'll have some fun. Take care. I've got limited office hours today, about 5:30 before my evening class, where we do 2151 again. All right, folks, take care and have a great break. I'll see you in a week and a half or so, a week from Tuesday.